I pulled it up.
Welcome to From Cover to Code, the Technology Book Club. Join us as we discuss artificial intelligence, DevOps, software development, cloud computing, and more. With your hosts, Angela Andrews and Michael Jenkins. The next episode of From Cover to Code starts now.
And we are live and in the building. How are you doing today, Angela?
Better than you.
I know.
I'm Gucci. I'm worried about you.
Yeah, well, for those of you that are joining us, I'm getting over a sinus infection. And so my voice is a little scratchy, but I'm going to press through. I've got my hot drink, cold drink, tissues, cough drops, extra meds if I need them. But we're just gonna push through. I didn't want to let this episode wait another week or day or whatever it took, because I feel like I've already said before or previously, this is a highlight for me during our week. So if anything else, this is going to energize me to get over this cold infection, whatever it is, even faster. So that's why I'm here.
I'm glad. Well, I'm glad you're well enough to join. I wouldn't want to be anywhere else but right here. This is something I too look forward to. It's the high point. It's just one of those things. We're here because we like what we're doing. We like what we're reading and learning.
Learning is fun.
Learning is fun. And don't let anybody tell you otherwise, because this has been from its inception. This has been such a growth spurt for me, technically. I wouldn't say professionally, because I'm still in the same role. Like, I haven't tried to do anything, but I take what I've learned here and it's so applicable to what I do all day, every day. So it's definitely a bonus for me. So I look forward to it. Every week I look forward to it.
Yeah, it's the best way to level up when you're reading, definitive guides and like the concrete information on the tool and best practices, and then you apply them, and that just like reinforces what you've learned. That's like the ultimate way to level up, in my opinion.
I'm loving it. But I'm glad you're here. I'm glad you're well enough to join. Let's get into it.
No doubt. We are in chapter 6 of
Say what
Terraform
now?
Up and Running. Yeah, chapter 6. Well, this is episode 5. We're on chapter 6, Managing Secrets with Terraform, and we're over the hump. We're on the down slope of this season. I mean, we've covered so much of Terraform in the previous 5 chapters of this book, that even if somebody read this far and sort of dropped off, they would already be capable. They enough to be dangerous with Terraform. And then I think from here on out, it's just kind of like sharpening the sword, honing your craft so that you could be even more dangerous as you hit the command line with Terraform. So, but secrets and keeping your credentials secure is definitely an important part of working with infrastructure as code. So I'm glad that Jim dedicated a chapter to this topic.
Samesies. I'm just going to jump ahead because there's a reading appendix at the back of the book. And of course, there are some books that we have read and some books we have discussed reading back there. So, we're not going to talk about it, but this book is the gift that keeps on giving.
There you go. Yeah.
So I am very, very excited about we're coming in for a landing. I mean, like you said, we have more chapters behind us than we do in front of us. And there's some goodies back there. So
okay. I can't wait to get to those and discuss them.
Yes. All right, let's chapter 6. What do we got?
Yeah. Well, I appreciate the Fight Club style that he used to kick this chapter off. Whereas like there's two rules
Say it
for
again.
secrets management in Terraform. And basically the first rule of secret management is do not store secrets in plain text. The second rule of secrets management is do not store secrets in plain text. Just don't do it. So if you forget rule number 1, refer to rule number 2.
Amen.
It just makes it easy.
He said what he said, and he kept saying it. Like, don't do it. Don't do it. And you think about it, even since the beginning chapters, when we started deploying infrastructure, I think it was in chapter 2 or 3. It was 2. We were not storing our secrets in our code from the very beginning. We were using environment variables. So I appreciate how he, as an instructor, decided to go with security first. We've gone through way too many tutorials in our lives and blogs and all kinds of things where they will put the hard-coded password in the code, almost like a default. We're not gonna get into all that, you know. I will tell you, I want to say, as the Terraform class that should not be mentioned. I think we were using I think we were using passwords in the code. So that's a whole nother thing. But I love the fact that from the jump, he was enforcing this without having made mention to it, but then dedicated a whole chapter to it because that's just how important it is.
Yeah. And I will say, like, to your point about lessons or tutorials, and they just say, yeah, just put the password code right here. It's a dev environment, or it's a practice environment. You're going to throw it away and all that kind of stuff. It's easy. And I've done classes like that before myself, where I'm like, it adds another layer of instruction to tell people how to manage this whatever it is, this credential properly. But if you do it from the jump, then you don't have to explain it down the road. So I do appreciate that he's taking the lead here and just said, hey, don't put your secrets in plain text. And even goes on to say, like, why it's a bad idea, and how if you check your secret into GitHub, you're done. Like, access keys in GitHub, somebody's going to find those and be mining cryptocurrency in your AWS account, probably in minutes.
In mere minutes
these days. Yeah, that's kind of how how sad, but at the same time important it is. But even beyond that, if there are other people who have access to the file systems where you're writing it in, the computers that may have checked out this code inside your company, anybody who can read that has access to it. If you embed it in your code, then wherever that code is deployed as software, people who have access to that, they can read it. And then if it's hard coded, you can't audit or revoke it very easily. You'd have to go through, whatever your build process is all over again. But then again, if you're hard coding it from the beginning, you're going to have that same problem just the same. So it just makes it hard. And like you said, just don't do it.
Just don't do it.
Use a secret management tool.
So that's a great segue into the section called Secret Management Tools.
Yeah, I'm reading from the book.
Oh, okay.
Directly.
It sounded very segue-ish.
I know.
Okay, you on brand then. So let's start with the types of secrets that you store.
Yes, indeed.
Those personal ones. We all have our SSH keys tucked away.
Yeah. Usernames, passwords.
In our home folders, and our PGP keys and username and password. I use what's it called? I just said the name of it. LastPass.
Yeah.
So that works for me. Yeah, those are personal secrets because they're personal for me. And then we have the customer secrets. And I've managed Active Directory most of my career. That was my bag, so all of the information that is stored in there, we're responsible for it. And let's see, you manage your company's internal AD, blah, blah, blah. There are other systems that manage PII and PHI, and there's so many acronyms when it revolves around the type of information that you can have store about people that you have to keep safe. You have to make sure that it's protected. Things are encryption and in transit and at rest, all that good stuff. And then we get to the good stuff, what we've been working with so far in this book, and that's infrastructure secrets.
Infrastructure secrets, yeah. That's your database passwords, API keys, your TLS or SSL certificates, all the stuff that the infrastructure needs to communicate, like server to server, server to API, application to other application, or something like that. Yeah,
running the gamut. And then now that you know about all those various secrets that you have to be mindful of, the next it goes on to how you can store it. And then he talked about the file-based secret store and the centralized secret store. So what's next?
Well, from there, he kind of goes over like the different secret management tools, and it's a pretty wide array of all the tools, the types of secrets they can work with, and the interfaces, whether it's the types of secrets, we just discussed infrastructure, personal, customer, whether it's a centralized or a file-based, and then whether the interface is through like a UI, an API, or from the CLI. And I mean, you would imagine that the CLI is definitely going to be for human use, right? Or at least scripted use.
Programmatic.
And the same thing for the UI is going to be a person going to a web page or something like that. The API though would be for like potentially applications talking to other applications to get their secrets, to store secrets, rotate secrets, that type of stuff. And then the tools kind of run the gamut from like pure CLI stuff. SOPs is one that I've heard a lot about, but I have never used.
Okay.
Where it basically encrypts files and stores them right along with your code, and you use the SOPs command to decrypt them when needed. I don't see LastPass in his particular. No, LastPass is there, along with other tools, the same line, like 1Password, Bitwarden. And then you got like on your OS level, Keychain, Credential Manager, and then the like some of the bigger ones, Active Directory, Auth0, Okta, OneLogin, and AWS Cognito, mainly for like customer logins and that type of stuff.
And then, of course, we delve into. So I will say this: there were some of these I'd never heard of. I
agree.
I've never heard of Confidant. That was new. Let's see. The other ones I've heard of, but you're learning as you go. There was something, and we'll get to it, called AWS Vault that I hadn't heard of. And because I wasn't reading near a computer, I never tried it. But at some point, I'm definitely going to give that one a try. So yes, so he goes over the types of management tools and the types of secrets that they are mainly used for protecting. They tell you what type of storage that you're dealing with, and the different interfaces in which to interface with the management tool. So good, nice long list there, depending on what type of secret you're responsible for. So yeah, that was a good overview with that. Now what?
Well, he goes on to say that, he gives this long list of the tools and the secrets and the ways you interface with them. But he's like, from here on out, we're looking at infrastructure, API and CLI, because that's mainly how Terraform interacts with the secrets. And how we interacting with Terraform, in turn, will interact with the secrets and how to store and protect them and that type of stuff. And the breakdown from there is at the provider level, resource and data sources, and then the state files and plan files. And those are like the main three, I think, categories that takes it all the way through the end of the chapter. Starting with providers, and the example that he gives is perfect example of hard coding your access key and secret key right there in your Terraform code.
There it is.
Where you can say provider AWS access key equals, hey, here's my access key. And then you check that code in somewhere. And guess what? Yeah, you're owned. They got you. So
Do not
basically,
recommend. 0
yeah,
out
do
of
not
10.
do that.
Mm-mm.
Yeah, but the important thing, I guess, about Terraform and the way that they designed the tool is if you don't put those secrets there, it's smart enough to look at all these other places. It'll
How
look
about
in
that?
your environment. It'll look for your profiles and try to find the files there so that you don't have to hard code them in the code. So I think that's thumbs up for the folks at Hashi that came up with that approach.
Out the gate.
Yeah.
Out the gate. So you talked about the different ways, environment variables. Like I said, we started that from the beginning of the book, and now he's just uncovering other ways that we can use our secret access key and our access key in a secure way on our local systems or in our personal password
Mhm.
stores via CLI. And then, of course, he made mention of something called AWS Vault
Yeah.
that
Yeah.
I've never heard of. And what do you think about it? You going to give it a try? Because it looks
Yeah.
very
I think.
easy to use.
Yeah, I think it's pretty cool. And basically, you add your secrets key to this store, this encrypted store on your system. I think he said it uses Keychain on Mac OS and Credential Manager on Windows. So it's securely stored in your operating system, and then you use AWS Vault exec and the profile name that you stored the
Mhm.
corresponding keys with to run your command. So instead of just running AWS whatever, you can run AWS Vault exec dev prod staging whatever, and then the command Terraform apply in this case, and it will provide Terraform apply with all the credentials that it needs to do a proper apply. And so I was like, okay, yeah, that's pretty slick. And I want to say there's other tools that do this. Some of them have been better or worse than others, and some have come and gone. I'm drawing a blank on the names right off the top of my head,
That's okay.
but this was the first time I had heard of AWS Vault being used in this manner.
I give it a try. It doesn't work on
Yeah.
Linux though. I see that
Oh man.
because I was like, "Ooh, that's waiting for an alias." Right? It's just
Yeah,
waiting.
exactly. Yeah, I would totally
But
alias that one up. But
yeah,
I guess if it's using sort of these native uh credential stores in your operating system, and I have used Linux for quite some time, but I am not aware of like what the native credential
yeah.
store is on Linux. Like,
All
what is
right.
that? Maybe that's something to exercise for the reader, for the listener, or for the viewer to say, hey, figure that
What
out,
is
and
it?
then go submit a patch for AWS Vault. Do a pull request on that so we can use it on Linux as well.
That would be dope. I mean, I'll try it on Windows.
Yeah.
I don't use Mac much anymore, but I'll give it a
Mhm.
whirl on Windows. I could do that.
Okay.
I'm
Yeah.
googling because now I'm just curious.
Oh yeah. Go ahead and get your Google on. But that was page 198 where he kind of gave a pretty good example of AWS Vault. And then he went into some examples with, those like AWS Vault, LastPass or LastPass and 1Password. Those are for us humans storing our secrets and retrieving them so that we can provide them to the commands that we're running on the command line. But then he gets into machine users, which is an interesting concept if you haven't worked with machines in a manner that provides them with the credentials and permissions that they need to do whatever it is they have to do inside the cloud. But that's the next section that he gets into. And he gives 3 examples here. Our Circle CI as a CI server with storage secrets, EC2 instance running Jenkins as a CI server with IAM roles, and then GitHub Actions as a CI server with OIDC. But before we move into those, how'd your Googling turn out?
Okay. It doesn't have a single built-in passenger manager like Windows and Mac does, but
Yeah.
it has something called GNOME Keyring,
Okay, yeah.
and it's used by Chrome, Evolution, Network Manager, SSH Optional, and something called K Wallet in KDE. So it's used by Firefox. Yeah, I'm not seeing anything that. Okay, I guess it stores passwords, key rings, credentials, application secrets. Okay. Known keyring appears to be the most common. You can use it in Fedora, a lot of the app-based and RPM-based OSs. So yeah, I'm gonna give it a try. See what we're working with here.
Okay.
Yeah. And there's something called Secret Service API. Yeah, there's something, but I've never heard of any of these. So it might take some digging into. All right. So we went over the three types of scenarios where a machine user could be used.
Yeah. And I think that for each of these, in my experience with each of these, all of these tools have some sort of credential store inside the tool.
Mm-hmm.
And I think he kind of shows this in the Circle CI, sort of like the base thing, because like GitHub Actions, Jenkins, they all have password stores where you can put your credentials inside the tool and then reference them directly as you're running your workflow or whatever. So that's kind of the example that he gives for Circle CI. But then the other two are kind of like where you really start to level up with your interaction, and I guess making your secrets protection a little bit more capable. And the one that he gives with Jenkins is the IAM role. And I've got a little slide here. You know, I love my slides.
I read this and thought of you immediately.
Right?
I sure did.
No doubt, because this is an approach that I've used, man, I don't know, throughout my career, working with systems on AWS. And it doesn't have to be Jenkins per se. It can be any server that you want to give permission to do something on your behalf. Or, you know, you want to run commands on the server and you don't want to have to worry about entering a password or access keys or whatever. It kind of does it for you automatically. But the steps and stages that you have to go through, there's like layers to it, right?
Mm-hmm.
And you define all of this in your Terraform, but you have to do it in this order.
Yes.
Per se. Yeah, it's kind of.
Let's go through.
Yeah. All right. So you start with your IAM policy, and if you're watching this or joining us live or watching this later on, I'm going to read this chart from left to right. So you start with your IAM policy, and that's basically where you define all the permissions that you want whoever is using this policy to have. So I could say EC2 star, and that would give whoever's using this policy all permissions on the EC2 plane to create instances, delete instances, read all the data and everything in that manner. So then once you have your policy defined, you attach the policy to a role. So you create the role and you say, oh, this role has permission to do everything that's defined in these policies. And then once you have your role, in the case of an EC2 instance, you create an instance profile. And this profile attaches the role that you define, and that role has the policy. So now any instance that is associated with this profile, and if I understand correctly, you can only have one profile per instance, but of course you can have multiple roles per profile, and you can have multiple policies per role. So you can expand or update your permissions as needed. And then once you have your profile in place, you can attach that to your EC2 instance, and it's got all these permissions that you define all the way back down to the policy. And that's kind of how it works. And I mean, Terraform is pretty good for letting you do this, and very natively too, because you can have JSON policies, and then it'll convert them to the Terraform format that needs to be in to get attached and everything. So I like doing it this way because you don't have to worry about doing stuff in line at the instance level, at the profile level, at the role level. You take it all the way back to the policy, and the policy is like that root, the baseline, and you make your changes there, and then you attach it wherever you need to use that policy.
Okay. Something very random. I always wondered why you can only attach one instance profile, and then but I see you can make your policies as diverse or as big as you need to. I always wondered that because and of course the first time that you notice it, you're like, oh man, now I have to combine all this stuff to get. That was my
Mhm.
first, my knee jerk. And I was looking for a way out of it. Like, oh, can't I just, no, you can't. So
Yeah,
that was a
yeah,
teachable moment for me. But then when you get comfortable creating your policies, creating your roles, attaching your role to your, then it just becomes, yeah, second nature for you. But I
yeah.
always wondered that. Hmm.
Yeah, yeah. No, that's how it works. And yeah, I mean, and once you kind of get the hang of it, then it just starts to make sense. You're
It
like,
does.
okay, well,
It
let me
does.
do this policy over here. Let me attach it to this role. Let me attach it to this profile. Let me
It's a
attach it to this
workflow.
instance. Yeah, it really is. And
So
then
let's
there was
move on.
the okay, so the one example, a sort of real world example that I had for this particular workflow was having a database password, the database that uses the password, and then EC2 instances or applications that need to access the database. So we're talking about three different resources here. One is the actual, well, I guess I did mention it, but Secrets Manager, where the password is stored, AWS Secrets Manager, and then the database itself, where the password is applied, and then EC2, which is using this password to get to the database. So the way that I would do this with Terraform is there's a random password resource. So you can create a random password in your Terraform and then store that in a secrets manager resource that you create. So, and then what you would do is apply a lifecycle rule that says if the contents of the secret manager location change, then don't worry about it. Just kind of go with the flow. Everything is fine. Because what you'll do down the road is have a Lambda policy or a Lambda function that updates that password to basically rotate the password. But you don't want your Terraform to get hung up on that. So then you go through the whole sort of workflow that we described. EC2 has permissions to read Secrets Manager. It also has permission to connect to the database or to do RDS commands. And then the Lambda function also has a profile that gives it permission to read and modify the secret as well. So everybody has their permission to do this stuff. And you don't have to modify anything manually. You can, and the really cool thing about it when I was working with the team that was using this approach is that we never knew what the password was. It's like everything just worked. But if you pin me up against the wall and was like, hey, what's the password to this database? I could not tell you, because I didn't know what it was. You would have to go into AWS and look in the thing because we use this random password from default, from the gate, from jump. And then we changed it immediately. And then we could rotate it using this Lambda function. And everybody, all the resources and systems that needed it, they just got it from the store. They never saved it. They just picked it up from where they were supposed to pick it up. So nobody ever knew what it was. It was essentially hidden.
Yeah.
I mean, hidden in plain sight, but encrypted and stored, properly and all that kind of stuff. But it wasn't laying around just anywhere for somebody to pick up. So I thought that was a really cool approach.
That is pretty cool.
Yeah, and we did it all in Terraform, which made it pretty slick.
So that's a resource that you mentioned called Random Password Generator.
Yes, it is. Yeah, random password. You can tell it how long you want the password to be, special characters, and that type of stuff. And Terraform itself will generate a password for you. But again, that you have to change it because that password is written to your state file. Well, that's the other
part.
And I got some notes about that as we kind of get to the end of this particular chapter. But yeah, so that's why we would change it immediately. Because that password that was written to the state file that Terraform generated was no good. I mean, it was good. It worked. It let us stand stuff up in an automated fashion without having to specify a password. But because it was written in state, we considered it exposed almost immediately. So we had to rotate it.
That's good to know. Okay.
Yeah.
So what's next?
Went
through our little workflow.
Yeah, the last one from this particular section that I had notes on was the GitHub Actions as a CI server with OIDC. I think it's on page 205. And I think for these sort of automated workflow systems like Circle CI, Jenkins, and GitHub Actions, this is really the way to go, because it's so hands off that you wonder how it even works sometimes. But basically, AWS in this case sets up an understanding with GitHub that says, hey, we know if this command is coming from you, then we'll know that it's valid. And then you scope it to your repositories.
Yes. Even down to the branch too.
Yeah, even down to the branch. That's even more key, because you could say like, hey, I want this particular repository to have these permissions and to be able to do all this stuff over in AWS. And it just works. Like, once you have it set up, you don't have to specify any secrets. You don't have to specify any access keys or whatever. You do your AWS authentication, or configure AWS credentials is the action that you would use. And you tell it, hey, we're using OIDC. This is the role that I want you to assume. And it just goes off and gets that role, and it's done. It's like very, very slick. So this is the approach now that I'm using for my courses, because I was one of those folks that said, hey, generate an access key, generate a secret access key, go over to GitHub, plug it in here, and then access these variables from your workflow. But now I'm like, no, what you're going to do is you're going to create this OIDC role over in AWS, and then go back to GitHub and say you're using this role. And it's so clean, so easy, and so much more secure.
And secure from the jump, like you said.
Yes. Yeah.
Okay. I have not played around with it. But yeah, maybe now if I see it come through, we're dealing with a GitHub migration right now. We'll see. Who knows? Yeah. Who knows what team is going to jump on this bandwagon for their authentication? I don't know. I haven't seen it yet. I do review quite a few repos. I haven't seen this yet, but now I'm gonna keep my eye out for it, because it might be something that someone's using and I just never paid attention to it. So
and there's lots of other ways you can use OIDC, but the way they have it set up in this particular case, GitHub to AWS, and you could do it, GitHub to Google Cloud, GitHub to Azure, and it's all pretty much the same authentication approach, where you don't have to share the keys. Everything is already shared for you in advance.
Nice. Let's see, where are we? We're talking about GitHub Actions and OIDC.
Yeah.
Let's see if there's anything. I have notes in my book. I have highlighting in my O'Reilly online. I was all over the place with this.
Yeah, you are everywhere. I was in the audio book and the PDF for me and for this particular chapter. So I wrote some notes to the side, but I don't have any sticky tabs or anything like that.
Yeah. Next is resources and data sources. And again, what does he say? Do not do this. When I say he is beating us over the head, we will not do it. We won't do. Don't you worry, Jim.
Yeah, you won't do it, because and that's the thing with these resources, like your AWS provider, like your AWS DB instance, they take parameters for access keys and usernames and passwords, and you can hard code them right there. But you shouldn't. You shouldn't do it.
There are other ways.
Got to do something different. Yeah, there are definitely other ways to do it. And he mentions environment variables. You can read from the environment and then pass those in as variables to the resource. Encrypted file. I haven't really used encrypted files as much. I'm drawing a blank on.
I've used them in Ansible for passwords, using creating passwords, using passwords, encrypted files. I've used that in Ansible. But environment variables, that one we've used already, and it's just so simple. Like who else is going to be on your machine? In this very simple scenario, it's just you and me and our demoing that we're doing. But you're still storing it in plain text, right? So it's still not that panacea that even the GitHub, when it creates its own password and you get rid of it and now it's just stored, it's stored somewhere. But hopefully it's stored encrypted where you can't look at it, where you can't see it. Even in these scenarios, when you're using encrypted files, you have to encrypt it immediately. Like
Yeah.
you run through bcrypt or whatever it is, and you make sure that your playbook points to this file. It can do the
Mhm.
decryption in Ansible. I've never done it with Terraform. Maybe it's similar. I don't know.
Yeah, it could be. In this case, he's got like some scripts and some YAML files. Well, I guess he's talking about KMS2. I didn't really follow this example very well because again, just to me, using a file, and again, like I've heard people talk about SOPs and the way that you can use SOPs to encrypt files that are local to your code and everything. But then I wonder, like, what's the key for the decryption? Like, where do you put that key? And now
Mm,
you're protecting and storing that key. And maybe that's something local to your system, local, and it's local but remote. On the other side that needs to decrypt it, there's a way to get it over there. But yeah, I figure for me, I always want to use a central storage location that handles all the encryption for me and everything.
so in each of the what do we call them? I don't want to call them use cases, the techniques that you can use this type of encryption. He gives you the advantages and the drawbacks,
Yeah,
which I think
yeah.
is great because depending on, where your project is, if you're jumping in on a project and you're figuring out how they do things, you might recognize one of these in your environment. Or what if you're, this is greenfield and you're doing everything from scratch or whatever, and you have
Mm,
to decide, well, what tool will work better for this? I do like the fact that he, at least with the environment variables, I didn't mark it in the book, but I think he also does the advantages and disadvantages of encrypted files. It's probably another
mm,
page on. So, oh yeah, he does. Using encrypted files also has its advantages, but it also has more disadvantages if
yeah.
you're counting the number of
Oh, wow.
uh,
Yeah.
the downside. Money. Like using these services actually
Mhm.
costs money, and depending on the number of API calls that you're
Yeah.
using, it could be very expensive. So, um, anything about that? Because then they have something called secret stores, which
Mhm.
is secrets manager.
Yeah. Well, and there's like for AWS, they've got AWS Secrets Manager. He goes on to mention Google Secrets Manager, Azure Key Vault, HashiCorp Vault, but you can also use AWS Parameter Store, and
Yes.
Parameter Store is free. It doesn't have all the capabilities of Secrets Manager. For example, I mentioned the one approach that we use for our database where we could create the Secrets Manager resource, put a random password in there, and then have a Lambda function that rotates the password for us. You can't really do that with Parameter Store. You have to use Secrets Manager because it has all these other capabilities that let
Gotcha.
you reference the previous value that was stored there. Parameter Store doesn't really let you do that. So, I mean, there are some fallbacks there where it's like maybe somebody loses access to the current value that's there. They can still access the old value that was there,
Right.
and proceed, particularly with databases, because you want your databases to be able, or connections to your database to be able to do what they need to do. But yeah, for my little use cases, personal stuff and projects, I just use Parameter Store because it's
Okay.
free. It works. You can encrypt values there as well. You can do them in plain text, but then they're still centrally managed. You don't have to
Right.
store them locally on your system or something like that.
Okay. I may have to look into, because in the code examples that we're using, you're actually creating a database and you need to
Hmm.
have your code have access to that database, right? So far, environment variables. At some point I'll have to take a look and see how would we do this in parameter store. Although I
Hmm.
think no, this example uses secrets manager. Never mind. This yeah. So yeah, I'll have to give it a try. But again, it talks about how these various secrets managers, secret stores have their benefits and they
Hmm.
too have their drawbacks.
Yeah.
As with all things. So you have to decide, you know, is it worth the squeeze? Does it protect your data the way that you want it to? If cost is a factor, you have to take that into consideration. Have you ever used HashiCorp Vault?
I have used HashiCorp Vault, and it's cool. It's okay. The one way that I used it, at least to me, it feels more like a file system than like some of the Secrets Manager definitely feels like a singular value. Like I'm storing this thing here at this location. But for HashiCorp Vault, it was like I don't know, like company name / team name / environment name / project name / database password /
Oh,
data,
okay.
so it's like this hierarchy that you have to kind of like manage or navigate to get to your value. Actually, AWS parameter store is kind of like that too. It kind of has that same, you can build paths out of it if you want to. But for me, it was odd going from Secrets Manager to Vault because I was used to just having one value. It was like, no, give me this thing and I want it, as opposed to having to navigate a path to get down to it. But I mean, it's cool. I'm trying to think of some of the funky stuff that we encountered working with HashiCorp Vault, where it's like some stuff you can lock it so that either nobody can read it or nobody can write it, and then you have to get somebody to unlock it so that you can update the value or read the value. And I could be recalling that in a, I don't know, funky kind of way, but I just remember it being odd. Like, hey, can you unlock this for me so I can read it? But it was that much more secure.
That's true.
Excuse me, to protect it. So
interesting. Nobody. I haven't come across a lot of almost any HashiCorp Vault users in this environment. Everybody's pretty much using Secrets Manager. Maybe they're using Parameter Store. I just haven't noticed. But Secret Manager tends to be the default at least in my organization. So.
Yeah, same for me. Parameter Store or Secrets Manager. That's pretty much what we're using as well. But there are some folks that use HashiCorp Vault too.
Yeah.
So yeah, we're all over the map that way, I guess.
Variety. All right. What's next? Oh my God, we're coming up on the end of it. So we're talking about state files and plan files. You did mention plan files just a moment ago. You'll come across those secrets.
Yes. I forget, like for the plan, you can save your plan off.
We did that.
Earlier on. It's like, hey, this is a plan that I probably want to run. And there, you can have Terraform apply that plan without even, checking for anything. It's like, hey, here's the plan, run it. But the state file too is like, once you've created these resources, and like, for example, if you do use that random password resource to create a password string, it's going to write it to the state file so that it knows how to reference it, what that value is later on. But if you now take that state file and put it somewhere where anybody can see that file, then you're still exposing the secrets that are in there. So the way that I've gotten around that, and I guess pretty much is a best practice, is to use an S3 bucket that's encrypted by default, and you're using AWS Key to decrypt it.
That's right.
So that way, when you write your state file to the bucket, then it's already encrypted by default. You do have that local copy though on your system, so you got to watch out for that as well. Got to keep an eye out for that.
There's always that caveat. So let's see. Does it go into the advantages and disadvantages? I don't think it does.
It just jumps right to the conclusion.
Yep.
Yeah. I mean, and he goes on to say, he does say encrypt your plan files, and control who has access to it. There was one thing that I wanted to mention from this. I made a note of it. Well, and that's the point that he makes is that Terraform will store credentials in your terraform.tf state file in plain text. Yes. This has been an open issue since 2014 with no clear plans for a first-class solution. Now, before we went live for this particular discussion, I didn't have the opportunity to check OpenTofu to see if they've already branched off and said, hey, well, guess what? We can do
We want to figure this out. What did you
encryption.
find?
So I didn't find anything yet, but while we're talking here, I'm going to Google.
Love that. So there was something else you mentioned that was kind of solved in OpenTofu that was more like an open item or something that hadn't been addressed in Terraform. And it, for the life of me, I can't remember what it was. You'd mentioned it maybe like 2 weeks ago.
I'm drawing a blank.
All right, maybe we'll have to go back to the tape and figure out what it was.
Yeah. Run back.
I'm gonna let you search. I'm curious to see if
I got it right here. So OpenTofu, state and plan encryption. OpenTofu supports encrypting state and plan files at rest, both for local storage and when using a backend. In addition, you can also use encryption with the Terraform remote state data source. So they've already implemented it. Maybe, the book that we're reading, it's some years behind where Terraform is. Maybe Terraform has already had state and plan encryption added as well, but OpenTofu definitely has it. So
that's awesome.
There you go.
That would be sweet though.
Yeah.
That would be one less thing you have to worry about. You can actually encrypt those plan files. Maybe we need to be Googling that too.
Yeah, well, that's what I'm looking here now.
Oh, you are? Okay, I'll leave you to it. So after that, let's go back and recap chapter 6, managing secrets with Terraform. You again used the Fight Club reference. Do not store secrets in plain text. I said, do not store secrets in plain text. And if you read this chapter, he's going to say that a few more times to beat us over the head with it. We got it. He also went over secrets management tools, the types of secrets that you store, personal, customer, and infrastructure secrets, the way you store your secrets, talked about the different ways you can do them, either file-based or central secret store, the interface that you use with your secrets. Most secrets management tools have multiple interfaces. You can use them from the CLI, you can use them from the UI, you can use them from the API, which is the clutch one because you can automate your workflow in accessing your secrets through that API. Let's see, he went over a list of management tools, what types of secrets that it manages, what that storage looks like for those secrets, and the different interfaces. And then he did that with that was a comparison of the various secrets management tools. And let's see, he talked about providers, resources, and data sources. And where we just ended up, this was a short chapter, just so you know. He talks about state files and plan files. And we're finding out that OpenTofu has solved this problem. And you were looking to see if Terraform solved this problem.
Yes. So HashiCorp Terraform CLI does not have native client-side state or plan encryption. If you're using Terraform Cloud, you do kind of get that. But if you're just using vanilla Terraform, you don't.
Okay. Yeah. Fair enough. All right. So we found that little tidbit out. Maybe it'll come one day. Maybe they just want you to keep paying and use
yeah, they want you to stay with Terraform Cloud. Yeah,
I'm sure that's where that's headed. And we're at our conclusion. What are your takeaways from this, other than do not store your passwords?
Well, I'm gonna go with the Fight Club reference and just if rule number 1 is not clear, then I'll refer to rule number 2.
Amen.
And either way, I'm covered. I will not store anything in plain text anywhere. I'm all for putting stuff in Secrets Manager parameter store and then accessing it from there. Using sensible defaults out of the gate and then changing those defaults almost immediately with a lifecycle rule in place so that Terraform doesn't get caught up on any changes down the road. That's pretty much how I operate.
Okay. Well, there's a conclusion, a comparison for methods for passing secrets. If they're environment variables, encrypted files, or central secret stores, a lot of plus check boxes or X's, what will work and what won't work. We know that environment variables is the free 99 version, all the way up to your centralized secret stores like Secrets Manager or Vault or whatever. Those are the ones that are going to cost you. Yeah, so that was, now that we understand how to manage our secrets, which is super important. I'm glad we broached this subject because security matters here. We're going to move on to chapter 7, which deals with multiple providers, multi-region, multi-cloud, multi-account, because that's where the real deal is. That's real. That's literally the real. So
and I love it. I've already got ideas and stuff, the practical and personal experience to share in this. Because when you're, the really cool thing about Terraform, when you're comparing it to other infrastructure as code tools, is that it can work with multiple providers. Where CloudFormation, and you're stuck with AWS, Google and their stuff, you're stuck with Google. Azure, if you're using Bicep and some of their other CLI stuff, you're stuck with Azure. But if you Terraform, you can touch all of these clouds from the same interface. I mean, your code might look a little different. Your credentials are definitely going to have to be all squared away. So it's a little bit heavier lift. But once you have all that in place, man, then you can be touching a lot of different things from one Terraform apply. And it's pretty slick.
Oh, I can't wait. I can't wait. This is a meaty chapter, ladies and gentlemen.
Yeah, it's pretty thick.
I can only imagine. There's a lot going on in here. I should probably start reading it now because
ASAP.
It takes so much time to get through these long chapters. But yeah, that's a good thing. Chapter 7, we'll be back next week talking about working with multiple providers. And I'm looking forward to that.
Yeah, can't wait. I'm gonna have to get to this code. We'll get to the book ASAP. Get to the code. Even what's after, immediately after ASAP?
ASAPier, I guess. Yeah, right. I don't know. There's not enough hours in the day, but we're gonna make it happen. We're gonna make it happen.
Got to.
Well, I hope you feel better.
Thank you so much. I'm already on the mend because, like I said, this conversation just energizes me.
I love it.
I'm already feeling better. So I'll be at least 95% by next week.
All right. We'll take it. I like those odds.
All right.
Thanks, everybody.
Yeah, thanks for everybody who joined us live. MySpace, Facebook, IG Live, all those platforms that we're not really on, and LinkedIn, YouTube, Twitch, all those other places where we actually really might be. Thank you all for joining us. We're glad you did. I know.
See you, everybody.
What is Twitch even doing right now? All right, we'll see you.
See you guys.